Okay, section 5. Here's the last section of class today, right? So this is a kind of a bigger lecture day today. But yeah, let's talk about here the last thing that impacts different sorts of bonds and explains why different bonds pay different interest rates. We talked about 3 factors already. We talked about liquidity, we talked about risk, and we talked about, geez, I'm having short-term memory issues here. We talked about income tax considerations. Thank you. Yeah. So now the 4th one, maturity. The maturity of a bond impacts the interest rate that it pays. Why? Right? Well, the way to think about this is to think about something called a yield curve. Okay, a yield curve is actually something that is a tool that markets actually pay a fair amount of attention to, right? So financial analysts spend a fair amount of time thinking about what's happening to yield curves over time, because as we're going to talk about, yield curves are actually quite an interesting indicator that gives analysts some insight into what's happening in financial markets. So what is a yield curve? All right, well, a yield curve, if I can show you here. A yield curve is the plot of the yield on a bonds with different maturities. So the bonds have to have the same risk, liquidity, and tax considerations. The only difference is they have different maturities. So for instance, we could look at treasury bonds and look at maturities from 3 months, 6 months, a year, 5 years, 10 years, 20 years, 30 years, right? What happens, right? If you plot this, here we look at the yield to maturity, and here we look at how long till maturity. Oftentimes, what we typically see is that yield curves are upward sloping. Sometimes they can be steep, like in this example. Sometimes they can be relatively flat in this example. So what does this mean? It means that in general, long-term bonds pay higher yields than short-term bonds. However, it's also possible that we could observe a flat yield curve, meaning that occasionally there's very little difference across bonds when it comes to maturity. And sometimes we even see the opposite occur, a downward sloping yield curve, where longer term bonds actually pay lower yields than short-term bonds. So why is this? Why is it that we actually in history see examples of all of these occurring, though in general we tend to see a mildly upward sloping yield curve, right? So this case B here is the most common thing that we observe with yield curves when we plot them, but we've seen A and C and D at different periods of time. Why is that? Well, first off, let me back up here and say, here's a couple of facts about yield curves. First off, we know that interest rates on bonds of different maturities tend to move together. We saw a graph just like this a little bit ago, that this is just for a shorter time period, but if we look here between 1950 and 2015, you can see so clearly that when one type of interest rate goes up, all interest rates go up. And when one type of interest rate goes down, all interest rates go down. We also know that when short-term interest rates are low, yield curves are more likely to slope upwards, right? So when interest rates are low, you tend to get an upward sloping yield curve. But when interest rates are high, that's when you're more likely to see those unusual downward sloping yield curves. Okay, that's a clue, right? That's a clue for us. When interest rates are low, markets think that longer-term maturities are going to go up. And when interest rates are high in the short run, they tend to think the maturities are going to go down. And then finally, on average, yield curves slope upward, right? So the average, or the most likely thing that we observe with the yield curve is that they slope upward, but they don't always do that. Okay, how are we going to explain this? What's a theory that helps us think about the yield curve? Your book focuses on multiple theories, but I'm just going to focus on the theory that I think actually makes the most sense. And this is something called the liquidity premium hypothesis. Okay, this is seemingly kind of a complicated theory, but I hope after I talk through this, I hope you'll see that it's not nearly as complicated as it looks initially. The liquidity premium hypothesis simply says that what should be the yield on a long-term bond, right? So let's say, for instance, a bond that has N years to maturity, right? N could be 20. What should be the yield on that 20-year bond? This theory says it should just be the average expected yield on one-year bonds for the next 20 years and average them together. So what should be the yield on a 20-year bond? What should be the yield on a one-year bond next year, a one-year bond the year after, one-year bond year after that, and then average that over 20 years, okay? But here's one additional factor. In general, what is safer for an investor, to hold a 20-year bond or to hold 21-year bonds? And the answer is it's safer to hold 21-year bonds. Why? Because you don't have to worry about interest rate risk as much. You don't have to worry about interest rates going up and eating away the capital gains that you could get with the bond, right? And so why would somebody hold a 20-year bond when they could just hold 21-year bonds? And the reason is because they get a premium for it. And that's what little l is here. Little l is the liquidity premium. And notice that it gets bigger, or it should get bigger based on how many years the bond is. So we've talked about before in this class about interest rate risk. And if you remember when we talked about, actually we did this yesterday, when we talked about calculating yields, we talked about how longer term maturity bonds have more interest rate risk. So what does that mean? To get investors to hold longer term bonds, you have to pay a higher premium on those. They have to pay higher interest rates. So the idea here about the liquidity premium hypothesis is there's really two things that impact how much a long-term bond pays. One is what's going to happen to interest rates over the life of that bond. Are interest rates going to go up? Are interest rates going to go down? And then the second is that you also have to compensate investors for accepting the risk of holding a longer term bond. So let's think about an example here. Let's say you have a 2-year bond, right? You expect interest rates in the first year of that bond to be 5%. You expect a 1-year interest rate in year 2 of the bond, T plus 1, to be 6%. And the liquidity premium to hold a 2-year bond has to be 1%. Then what yield should you demand on a 2-year bond, holding a 2-year bond instead of holding each of these 1-year bonds? Well, first you should take the average of these two, so 5 plus 6 divided by 2, and then you have to add in the premium to compensate you for holding a 2-year bond instead of a 1-year bond. So this is our formula, and you notice this is just a version of this formula up here. First, we average the two interest rates, and then we add in the liquidity premium. And the answer is 6.5%. That is how much we would have to be compensated to hold a 2-year bond instead of 2 1-year bonds. So we could make a more complicated example than this, right? We could have 15 years, but really the idea is the same. You just average the interest rates that are expected to happen over the course of the bond, and then you add in this liquidity premium, right? This theory helps us understand why yield curves are generally upward sloping, because generally interest rates are expected to go up in the future. Or I'm sorry, let me back up. Yield curves are upward sloping because of the risk premium, right? So if interest rates are expected to be flat, the yield curve should still be upward sloping because you demand a higher premium for holding a long-term bond. The other thing that could drive yield curves up is if interest rates are expected to go up in the future, right? So you notice here that in this previous example, because interest rates are expected to go up in the future, that actually increases the yield that's demanded on a 2-year bond relative to a 1-year bond. So yield curves are upward sloping in general because of the risk premium, but they can also be additionally upward sloping if markets think interest rates are going to go up. Now, when could you get the unusual circumstance of a flat or an inverted curve? That's going to happen when interest rates are expected to fall. In fact, if interest rates are expected to fall enough, the yield curve could get flat or even downward sloping, right? So the only time that you would expect to see a flat or an inverted yield curve is when markets think interest rates are going to go down in the future. And so this liquidity premium hypothesis helps us explain our three facts. It helps us understand why different interest rates at different maturities tend to move together. It helps us understand why yield curves typically slope upwards, but that sometimes yield curves can slope downwards, okay? Let's talk a little bit about why markets pay so much attention to yield curves. And the reason is that yield curves are a way of forecasting the future, because yield curves are an indication of what markets think will happen to interest rates in the future. We talked earlier today how interest rates are pro-cyclical, right? When output goes up, interest rates tend to go up. And when output goes down, interest rates tend to go down. So what does that mean if a yield curve becomes flat or inverted? It means the market thinks interest rates are going to go down. Why would the market think interest rates are going to go down? Because they think the economy is going to slow down. So in other words, many economic forecasters pay close attention to the yield curve because they see a flat or downward sloping yield curve as an indicator that economic activity is going to slow down. So let's look at some examples here of different yield curves. And I think these different yield curves, we can kind of maybe make some reasonable assumptions about what markets were thinking. Here's the yield curve in July 24th of 2017, and you'll see it's somewhat upward sloping. Notice here in 2006 what the yield curve was. Notice it's much higher than it was in 2017, but it's also much flatter. That's a classic example of a flat yield curve, and that could be an indicator of a recession. Notice that this was in February 2006. We, in fact, did have a recession in late 2007. All right, so the recession was still a year away, but it was coming. Here we see a relatively flat yield curve in March of 1997. Here, the yield curve didn't do such a great job of predicting. We didn't have a recession until 2001, so a recession was still 4 years away. Here's another example of a flat yield curve in May of 1980, where we were in the middle of a recession. And we ended up having another recession in 1981, and you can see in 1981 how inverted that yield curve was, right? So notice here that the yield curves are all exist at different levels, right? Here, notice how high short-term interest rates were. This is right after the big inflation of the 1970s. The fact that interest rates were so high here suggests that the market thought interest rates were going to go down in the future, but part of that going down also meant that the economy was going to slow. And that's how we get such a dramatically inverted yield curve here. So listen, interpreting yield curves is not a science so much as it is kind of an art, right? You kind of have to look at these things and see what's, kind of wave your hands a little bit and try to figure out what's going on. One of the things we noticed here this last summer was that we had an inverted yield curve, or a very flat yield curve. So here's the yield curve from June of 2019, and look how inverted it was, right? There's actually downward sloping for a period of time. And so in the summer of this year, there was a lot of talk about how we were going to have a recession. This is even before the pandemic, right? This is well before the pandemic hit. So one of the things that many economic observers have been worried about was that the US economy was kind of headed for a recession even before the pandemic hit, There's this kind of nifty little tool that I want to just show you of, and we'll see how well this works. in Zoom. Sorry, I'm trying to find where this is. No, that's not it. Well, I'm sorry. Oh, I guess I can't find it. There's a tool I wanted to show you of using this yield curve dynamically and looking at different spots, but I'm not sure that this is working now. So maybe we'll just end our lecture right there, right? But just to back up here, it really is important to understand what a yield curve is, right? If you ever become a financial analyst, one of the things that you will spend some time on is looking at yield curve, because people in markets believe that yield curves are to some extent a crystal ball, right? They at least tell you what markets are thinking is going to happen in the future. They may not tell you what exactly is going to happen in the future, but they give you some idea what other people are going to happen in the future. And so, those flat or inverted yield curves are really an indicator that things are going to turn south, right? As opposed to a very steep yield curve, which is often an indicator that the economy is going to recover. So, I guess maybe one way we can think about how one indicator of when the economy is going to get better after this pandemic is when the yield curve begins to get a lot steeper than it is right now. I wanted to show you what the yield curve looks like right now, but one of the things you'll see about the yield curve, it is very, very flat, right? It is very flat. And just another indicator that if we are not in a recession already, we are soon to be in a recession going forward. So, all right, that ends it for today. We made it through the whole thing. So hopefully you are well. Remember that your first homework assignment is due on Friday, right? And you should submit that via email. Do that before midnight. Tomorrow we will be back on day 5 of lecture to talk about stock markets. All right, so we're going to move off. This kind of finishes our discussion of bond markets, and we're going to move off onto stock markets and talk about that for a little bit. So we'll do that tomorrow. All right, hope you're all well. Be well. Take care.